next point, can MRI help us understand the cause of long-term disability in MS? So after 15 years, we've got this group of people, some of whom have been very severely affected by MS, some people who have been very mildly affected by MS, and then a whole lot of the middle. And one of the things that we're looking at that we can't do with ordinary MRI scans is what's going on in the grey matter. So your brain has two main bits, the white matter, which appears more pale here, and the grey matter, which is this ribbon around the edge. We know from autopsy studies from people with MS who have very kindly donated their brain when they've died, pathologists tell us that there's just as much going on in the grey matter as there is in the white matter. But with ordinary MRI, we just don't see it. The things that are happening in the grey matter are lesions, focal areas of inflammation, but also atrophy, loss of nerve cells in the grey matter. And we think grey matter pathology is important in terms of disability, but also for cognition, memory, thinking, concentration. And something that's not common, but overrepresented in people with MS is seizures from scarring in the grey matter can give rise to seizures and epilepsy. That's about 1 in 20 to 1 in 18 people with MS will have seizures and epilepsy as a result of their MS. And that's due to involvement of the grey matter, we think. However, when we do an ordinary MRI scan, while we can see these white matter lesions really well, these white spots here, the grey matter all looks pretty healthy and looks okay, and we can't actually see any of these changes that are going on in the grey matter. So we wanted to investigate the grey matter with a new special kind of MRI scan and to determine whether these involvement of the grey matter, these lesions, might be related to disability and cognitive problems. And this is what one of these new MRI scans look like. You can see that they fiddle with the knobs on the MRI scanner, so it does look quite different from an ordinary MRI. And it also is very, very detailed. You get 90 cuts through the head here, as opposed to, remember I said at the Auckland Hospital you might get 25 cuts for an ordinary MRI brain scan, so very, very fine levels of detail. And you can see here the very typical lesions shown with a red arrow that we wouldn't be able to see on an ordinary MRI scan. Let's just show on this side too, lesions here that show up really, really nicely on this scan that otherwise we wouldn't see. The scan actually, although I told you that people were usually in the scanner for about 2 hours, this particular scan only takes about 7 minutes. So we get these beautiful pictures in quite a short amount of time actually. Now we've had a look at this in the first 50 people that came back, so these are very preliminary findings. But what we found is that people who have secondary progressive MS have higher numbers of lesions in the grey matter, and that the number of lesions that they have seems to be related to disability. So the more disability, the more grey matter lesions. We've also found that in the people who have not developed MS, remember there's some people that just have one attack and nothing else happens, the involvement of the grey matter is really, we just don't see it in those people. And so it suggests that looking at the grey matter might give us some information about disability that will be helpful for us going forward. Something else that we don't see on ordinary MRIs, but we know is a problem, is what's called the normal appearing tissues. So just because something looks normal on the MRI scan doesn't mean it's normal if you look at it under the microscope. And in the bits of the MRI scan here where there are no lesions or changes, if you actually took that bit of brain out and had a look under the microscope, there is inflammation going on there, and there's loss of nerve cells. And we just can't see that with an ordinary MRI scan. One way of approaching this is a very special new sort of MRI scan called sodium MRI. So an ordinary MRI scan picks up water in the brain. Now our bodies are just all salt and water, basically. And so instead of picking up the water, this sort of MRI scan picks up the salt. We know that there's higher levels of salt in the brains of people with MS, and we're trying to work out why that might be. For this MRI scan, you actually wear a headband, okay? And inside the headband are 2 test tubes. So this isn't someone with a very funny looking brain. These are 2 test tubes. And inside the test tubes is salty water. And we know how much sodium is in the water, and then from that we can calibrate the scan to measure the concentration of sodium within the brain. And these are the sorts of pictures that we get. On this scan here, the darker the area, the higher the sodium concentration, and the more blue is the lower the sodium concentration. These are ordinary MRI scans that we would do on a standard hospital scanner. And you can see here a very typical MS lesion. And you can see that within that lesion, compared with the brain around it, that the levels of sodium are higher. And we think that's because there's loss of nerve cells, or one reason might be it's because there's loss of nerve cells, or that they're not working well within that lesion. These are 3 people from the study. This is my brain. So we're also scanning people that don't have MS so that we know what the changes are. This is someone with relapsing remitting MS, and this is someone with secondary progressive MS. And you can see that in these bits of the brain that look quite normal, where there's no lesions on all 3 scans, there are differences in the amount of sodium. Okay, as we go from someone without MS to someone that's mildly affected by MS to someone that's more severely affected by MS. So there's higher levels of salt or sodium there. The high levels of sodium seem to be within the lesion, so that's where the levels of sodium are highest, but there's also high levels in the areas of the brain, the normal appearing tissues like the grey matter and the white matter, that we don't see anything on the ordinary MRI. And high levels of sodium in these tissues, but especially in the grey matter, seems to be related to disability and the early development of secondary progressive MS. What we'd like to know is, why are these levels of sodium increased? Is it because the nerve cells have been lost, and if tissue is lost in the body, it has to be replaced by something? Has it just been replaced by salty water? Or is it because the nerve cells are there, but they're not working well because of demyelination? And we know that demyelination has a significant impact on the function of nerve cells. Dr. Brownlee before mentioned the new medicine Vampira that improves the way that nerve cells conduct electricity, and we can see improvement in walking in about 1/3 of people treated with that drug. So these high levels of sodium actually might be because these nerve cells aren't working well. We're taking this further. If we knew which of these 2 things that this type of MRI were picking up, then it might have implications for trialling new treatments to protect those nerve cells, like he mentioned before, the medicine phenytoin, which blocks sodium channels in the brain and protects nerve cells after an attack of optic neuritis. And this sort of MRI scan might be used to prove whether treatments like that are actually helpful. So where are we going from here? Over the next 6 months, I'm hoping to complete all of our long-term follow-ups. So the remaining 40 or 50 people that we've got left to follow up. Finish analysing all these MRI scans. The patient might spend 2 hours in the scanner, but I spend 2 days looking at their brain. So there's quite a lot of work to do doing the MRI analysis. We're hoping to have our first results next year, and I'll be busy working on those for another 18 months or 2 years at Queen Square, and I really hope to be back at this meeting in a couple of years with some more definitive results from our research. Now, that's the end of that presentation. I've actually added a few more slides on. After I was listening to Dr. Broadley's presentation, I thought I wanted to tell you a bit more about what's happening, not just what I'm doing at Queen Square, but some other MS research that's going on there. It's really, really exciting. So this is the end of the sort of first bit of the presentation. And again, I acknowledge the MS Society and the Neurological Foundation in New Zealand